thanks for showing up to one of the later talks this day. There are still 3 talks left afterwards. So for the other conference. The name is Stranger SQL. Someone asked me, is this a sequel? Was there a talk about Strange SQL? No, it Stranger Things maybe as a series, so this was a bit the inspiration. So I start with a joke. So you have to read it yourself, it's too much text. So why do I show a joke at the beginning? Because from my point of view, semantics matter in general, and especially in this talk. And the other reason is, this talk, I said it will be funny. So this was the joke and this was the funny part. Okay, my name is Philipp Sabesberg. I worked for Trivadis for almost 25 years. And since later this year, I started my own company. So I'm the CEO, the owner, the founder, the responsible for the printer, everything, So it just sounds a bit good. And I still have my blog. You find on my blog my talks, the slides and so on, and further information how to contact me. Why this talk? Crazy guy, developed a parser called IslandSQL, and the IslandSQL parser covers everything in SQL scripts for Postgres and Oracle database. So it's SQL plus commands, it's SQL CL commands, it's PL SQL, it's SQL of both dialects, it's pSQL from Postgres, so basically everything. And while I was doing that, I discovered a lot of differences in the dialects. Some I was aware of and some I was not. I learned a lot of things and I thought maybe this could be interesting for others as well. So that's the reason for my talk. At this point, the question, who is working with the Oracle database? A lot, huh? And who is working also with the Postgres database? A few, huh? A few. Always a bit more. Okay, so that was the reason. And let's start with the first things. We start with simple things. The first thing, comments. We all use them. We use them a lot because it helps documenting the code. And but they are different. But before, I want to show a setup script. And I'm very proud. It's the first time I can show a setup script for the complete demo on a single slide due to the new syntax we have. And this syntax, as we have here, works in Oracle database and in Postgres database. And I always want to try to do my demos based on depth and enp. And in Postgres, we don't have them by default, so I use that here as a starter. Okay, let's start with multi-line comments. On the left side, you see Visual Studio Code representation in SQL Developer. And on the right side, you see also Visual Studio Code representation with the default SQL syntax. You have different languages which you can enable. And you see it's a bit different. Okay, I cheated a bit here with the nested comment. It's not really highlighted there in another green color. But you may imagine that the result looks a bit different, even if the code is 100% the same. And it's no surprise when I run that on the Oracle database, the table gets dropped, and afterwards I cannot do the query anymore. And on the PostgreSQL side, they understand nested comments on a lot of levels. I tried 15 or something like that. This works. And this is SQL standard. And there's another thing, maybe I do not close the comment on the Oracle side. The Oracle has a problem. The first / ends the comment. But on the Postgres side, it just waits on the end. So when I run that on the Oracle database, I get 14 rows. And on Postgres, I get nothing because it still waits on the other, on the other closing part. So that was the first difference. And believe me or not, I found a lot of code in the Oracle space which do not properly close them. So yeah, it doesn't matter, but maybe it matters when you switch to the other database. Let's look at identifiers. Here's another example, a small setup. I created a column in lowercase a and in uppercase a, and I populated with lower and upper, just with a different that it's easier to see. And now the question is, when I do a query like that, I select A in lowercase, in uppercase, what are the results? It's clear for column C3 and C4, I guess, but what are the results for C1 and C2? Let's look at an example here. Just have to check something. Not yet. So, what is the result on the Oracle database? It's no surprise. I guess most of you are working in the Oracle space. It's upper. It just selects here the upper value. It's the same. And I wouldn't have shown that if it is the same result on the Postgres side, right? So, of course, it's different. And in this case, the Oracle database is compliant to the standard, not PostgreSQL. And why is it not compliant? Yeah, they decided early in the days when they implemented that they will do everything in lowercase. So that's the reason, and changing that is difficult throughout the code, but also from compatibility point of view. It's something you don't change. We have other things on the Oracle side which work the same way. We see that later. Let's look at identifiers and operators. So I have here another example. I created a table with a column, a b column in a hash b column, and a hash b column in uppercase. When I query that in the Oracle database, it's clear I have here a select a minus b. That's the column with value 1 and 2. That's -1. And then I select the column with a hash b, and it doesn't matter, it takes the uppercase variant, therefore I get 42. And now, not the question what the result is, but the question is, why do I get 3 in the Postgres? Has anyone an idea why I get 3 in Postgres? Huh? Yes, nice. It's actually the hash is an operator. You see, when you discover this Ovomaltine chocolate at the upper right side, then this is a price question. Huh? Okay. In fact, really the hash is an operator in Postgres. Indeed, it's an XOR operator, so it's binary 1, 0 and binary 1 added together is 1, 1 is 3. Logical. So these are semantics where it matters. Then when we look a bit closer at identifiers, at unquoted identifiers to be precise, there is no surprise that the standards say A and Z can be used as the first character, and A and Z, normal Latin letters, can be used also as a subsequent letter. Also for the digits, they can also be used for the subsequent letters. The hash symbol, that's what I showed here. It works in the Oracle database, but not in the Postgres database. Underscore works also in Oracle and Postgres. The $sign works also in Oracle and Postgres as a subsequent letter. We can use even Latin letters, Greek characters, Japanese characters, Chinese characters. Don't ask me to help you optimizing these queries, but this works. Now, another question, another chocolate at the box. Who knows which column is filled here for emojis? Which database supports emojis on the first and the last character? Who thinks? No. Yes? That's right. More. That's half of the answer. But it's enough. It's 3 days. Huh? In fact, that's quite cool because this is the funny part. Because if you want to create a table named with the smiley, you put the nice stuff there, and if you have some shit data, you use the shit emoji. That works. Why it works, why it is supported, don't ask me, it works. Okay, let's look a bit closer at identifiers and keywords. You all worked with joins probably, you all know the wrong join, right? No? What's the result here? It's 14 rows. The wrong join produces 14 rows. What is wrong here? It's an alias. It's no chocolate here. You can answer. It's an alias. But of course, we have also the right join, right? And the right join produces a different result. It produces 15 rows on both sides. That's okay. But now the funny part begins. What is right now? We have a lot of rights. The first right is the name of the query. The second right is the reference to this name. The third right is the alias. It's silly, but it is the alias. And the fourth one is a keyword. Right. And do you think it works in Postgres? Huh? They know the right join, right? No, it does not work because right is a keyword. And the SQL standard says you must not use keywords as identifiers. Okay? Good. And why? Maybe mention why does Oracle support right as an identifier? It's historic. You cannot just introduce new keywords and forbid the customers to use a table called right or something like that. It does not work. You have to be compatible. And why was it easy for Postgres to support it? Because the first version of Postgres was 1996. And the SQL standard already known about the right join, and they used that one, so they were just lucky. Okay? But for the newer things, they have the same problem. So string literals. You know them. Hello world, I can write that. It's no surprise Postgres can write the same syntax as in Oracle DB to produce that. But maybe this one is a bit surprising. This is hello on the new line world, and it produces the same result as the previous query. Is the SQL standard compliant? Of course. That's SQL standard. It's even worse. You can write it on the same line. You just have to add a single white space in between, and that's concatenation. Don't ask me why this is necessary. I think concatenation operator is there for a very long time. But you don't have to argue why something is in the SQL standard. It is for whatever reason. Then we have the Oracle database. Of course, the second syntax does not work, and the last one works again. So just don't use this stuff. It's silly. Then we have strings. You all remember them. When we want one apostrophe within a string, we have to add 2. When we need 2, we have to write 4. When we need 3, we have to write 7, because to terminate the last one. So there's a better way, right? You all know them. Since Oracle 10, there's a better way. And this is the Q syntax Oracle invented. You can use Q, and then you can use variant styles of brackets. You can use various. This is really a nightmare, depending on what type of parser you're using. Parser, it's to support all these variants. You can use symbols. You can use various letters also, not to produce that. And that is also a funny thing. If you think you have a monospace font, there are some characters which use a bit more. It just does not really work. So. And Postgres has, of course, something different. They, about the same time, they brought up this dollar syntax. You have a dollar at the start and the dollar at the end, and everything between is just a string. Some think that it's just used for procedures, but it's just a string in Postgres. And there's also an alternative variant where you can add an identifier. If you nest them, then you have dollar identifier, dollar at the end again to produce that string. And we learned a valid identifier in Postgres is also emojis. So if you like a string, you can add a smiley there. So, okay. And these nested strings are relevant, especially when you're generating code. Yes? Dollar. A column. You cannot. Then you just have to use another identifier. Then you can use $ID, dollar, and then dollar, then everything is okay. That's why these different syntaxes exist. So, yeah. So I just wanted to show you, typically you use that when you generate code. It's a silly example, but it's small. All of us have done that, maybe to delete all tables in a schema or something like that. So you can just define here a query. On the outer query, I use this brackets, and in the inner line, I use the normal parentheses for the strings. I highlighted it also with the color, and this query is just producing. That's cool. It's a lot of code, and what I like at Postgres, there were some Postgres versus Oracle sessions here. But what I like at Postgres, they have some nice development features in PSQL. You just can say, hey, I just want to execute that string here, and for every row and every cell you found, just execute what you found there. This is the gexec command. And then what is optional here, but I just enabled it to see what query was executed. This is a nice thing. Really a nice thing from a developer point of view. Postgres has some nice things there, which I envy a bit that they have that. Let's look at the data types. Postgres has tons of data types. It does not matter. And it's okay that they have that. But what I like is when something is called the same, I also expect the same semantics. So for char, that is true. For date, this is not true. In Postgres, we have a date without time. In Oracle, we have also there a time. And probably the most known differences here is for varchar and varchar 2, or varchar. The difference in Oracle and Postgres is that an empty string is not the same as a null, usually. I show that based on an example. It's absolutely the same query on both sides. I just have a row which is called null, and it contains a null value as the second column, and an empty with an empty string there. And the result of this query here is it null, is it empty, and both is true because Oracle treats an empty string like a null. It's the same thing. But for Postgres, this is different. An empty string is not null. And this is SQL standard. And I know there are reasons to say this is bullshit, because when I want to have a mandatory not null column with a name. I don't expect that someone has an empty string there. But maybe there's reasons. Whatever, it's different. And it's a pain if you have to migrate an application with this, where this matters. That's our small things. Now, the bit more interesting things come. Functions. Substring. Everybody knows substring? You think. It's a bit a special style what I do here. Substring 1 from 5. This is easy. The result is hello. But Oracle is, when you use zero-based, I know what you mean. It's the first character, of course, and I get you the first 5 characters. That's what you meant, huh? So I'm nice to you. And they have also some interesting interpretation of the second parameter, which is the starting position. When it is negative, it starts from behind. So 6 characters here, so, and then 5 characters from there. That's world. So, in fact, you have a write string in Oracle. Yeah? This works. But of course, this is not SQL compliant. When you look at the SQL standard compliant, what did you look what Postgres is doing, then it produces the same result for the first one. But for the second one, you just get hell. Complete different meaning, I think. And the starting position is 0. So, in fact, this is the starting position, and it's 1 character on the left side. So, it's null plus, you see how this works? And therefore, we also get -6. The implementation is very, very detailed, documented in the standard. And it's strange, but it is how it is. But in fact, it's not documented in the standard for substring, because for substr, it's documented for a function called substring. And this is the same for in Postgres as substring. So therefore, you cannot say Oracle database is not compliant to the standard. It just does not implement substring. Okay? Greatest and least. This is really, really silly. I tell you why. You look here, and what do you expect as a result? Who thinks we get, it's just no chocolate question, but who thinks what we get in Oracle for the first 2 columns? Both time null. And what do we get in Postgres? 2 and 1. And what is the standard saying? And believe me or not, this is introduced in the standard in the latest edition. Somehow Oracle managed to say what we have implemented. This is the standard. So I think we get some majority in that gremium, I think. Okay, why do I think it's silly? Because when you look how min and max is working, they just ignore the null. But for every single function, the standard defines, in this case we do it that way, in this case we do it that way, and it's not concise. But it's the standard. So just to be the standard does not mean it is good. So, okay. User-defined functions. It's also nice. Who has used functions in the Oracle database? And Postgres? They exist. Let's look at a simple example. I have here 2 functions. The first function does just conversion of an integer parameter to a char value. So it's a return to char, the first parameter. The second parameter does something similar for date. It converts it in that format. In Postgres, the syntax is quite nice when you can choose here the language. And one of the options of the language is SQL. And when you have chosen SQL, you don't have to pass it as a string. So you also get get quite a terse syntax. So it does the same thing. One parameter is the integer, and it will be converted here to varchar, and the second one is a date, and it will be converted to a varchar. So on the result, when I run that, I have created two functions. So far, so good. So let's call this previously created, and be aware you can win a chocolate again. What happens when I call that first one? So just execute the first one. The first one returns the result here. The 21st, yeah, it's sysdate, huh? Quite nice. Okay, and the second one, what will return that? An error in Oracle database, and it works in Postgres. Anyone an idea why? Yeah, what is the identification of such an object? It's in the Oracle database. We have a function identity which is based on the object name itself for the function. So it's just the f. And what I created, first one, I created the function for the conversion of the integer, I thought, and then the second one was for the date, and then this has just replaced it. Huh? But in Postgres, the function identity includes also the arguments. Not the names, but the list of the types. And therefore, we have in Postgres 2 functions, and in Oracle database, just 1. And yes, in packages, but this is just standalone. It's not funny to show something which does not exist on the other side. They don't have packages. Nah, it's not completely right. With the EDB, you have something like that. But yes, this is really when you start doing something and you want to delete, drop a function, or you do a create or replace and say, no, I don't want to pass an integer, I want to pass a whatever. Then you have 2 functions. And you want to drop it, you cannot drop it because you have to specify, in that case, a bit more of values. So that's just different. You have to be aware of, and overloading works a bit on that level when you use, for example, default values. And of course, it works quite well with packages. And in Oracle database, packages is the way to go. And of course, this is the SQL standard. Select statement. Oh, cool stuff. We got 23 AI. It's a promise that it comes next year, I heard. And we get this cool functionality, the from clause. When you can skip it when you don't need to pass it when you query from dual. You can avoid that. But did you know that Postgres is even able to live without a select list? Huh? Oracle again behind. Huh? This is something we always wanted. I have to write less here, and I just can say select or can select from without the star. Star is on the upper side of the keyboard. It's very complicated to put it in. So I know I have 4 rows. Does this make sense? No, huh? Well, I thought a bit longer and came up with a use case where I thought, in my opinion, it can make sense. I remember in the old times when I started, I had long hair once. And in that area, I thought, why the hell do I have to define here in the subquery some columns which are not used? I have to define them. So in Postgres, you can skip that. And how nice is that? It's a small thing. It's a small thing, but it can make sense from my point of view. But when you just see that and you see a missing select list and say this cannot work, but in fact it can work in Postgres. And people are using that. I found that out when I used my parser against the open source code. Okay, so now we have select semicolon, that works. Can we go further? Can we get rid of the select? Is that possible? Yeah, of course it's possible. We can just write table depth. And table is not a separate command. Table is just also part of the select statement. You can write something like select star from table depth. In fact, it just means select star from depth. It's silly, something on the funny side, I think. But it's used. When you look at the code, everything is used. A cool feature is the returning clause. I really love the implementation of Postgres. Here's a small example. The begin is not the begin of a block. It's just the begin of a transaction because I want to roll back it in the end. And in Postgres, you can use the returning clause on the update statement directly in the update statement here in SQL. So I have here updated some salaries, and I want to get the result, the returning rows where I changed the salary. And what I get back here is the same thing like I did would do with the separate query. So it's also a query result I get from an update when I use the returning clause. When I have to write something in Oracle database, does that work? No, it does not. But is there a similar feature? It is, yes. You can do that with PL/SQL. You see, it's not that complicated, and you get all the result as well. But just in PL/SQL, it's not everything is bad. What's really cooler is that I can use here this, and I have the returning clause. I can use the old and new value directly. That's a newer feature. That's really cool. That would help me to avoid building the old value based on the formula. Besides that, that's really complicated. And these things could help me implementing archiving, for example, without partitioning. When I have partitioning, there are much cleverer ways to do that. But let's imagine, for whatever reasons, we cannot use it. Then you just can use a with clause. In the with clause, you can do the delete. It's really different in Postgres. It's not based on select also. You can use in the with clause the delete, and then return just everything which you have deleted. And then this result can be used for subsequent insert. It's quite cool, I think. It's quite cool. And in the Oracle database, there are probably various ways to do that. One way, you could drop the table if it does not exist. You can create the archive, then you can select everything, create a new table just with the same structure here. I lock it that nobody else is doing something bad. Then I copy everything over and then I delete it. When it's a lot of data, I have two scans of the table, so it's not that nice. You can do that, but again, these are the small things we developer, not the DBAs, we developer love. Of course, it's a nightmare from changing the transaction model behind the scenes, but I don't care. I'm just a developer. It's a cool thing. Yeah, you have tons of variants to really implement it, but nevertheless, it's a cool thing, this returning clause. And you have it also in Postgres 17 for the merge statement. You can do a merge, and then you get everything which was merged, inserted, updated, deleted with an additional column. How cool is that? Transactions. But not everything is cool in Postgres. just a small setup of my test. I drop a table T, then I create the table T1, and then I create a table T1 with a primary key, just one column ID. And then I create the procedure where I pass in an integer, and this will be inserted into this table. This time I use PL/SQL here. No, this time I use PLPG SQL. Always have difficulties with this language name. And then I have to pass here a string. I used normal string here just to use the color highlighting of the tool behind the scenes. So this is nothing special. It's really a small example where I'll show you the different behavior of transactions. And when I do something like that in the Oracle database, I start the transaction read-write just to use the same semantics as in Postgres. Then I call procedure P1, insert 1, call procedure P1 again with the same parameter, then do a commit, and let's see what we get as a result from T1. So I started the transaction, call complete. The second one just fails because unique key violated, looks good. And when I do the commit and look afterwards, what do I have in T1? I have one row. Oracle database developers say, yeah, what else? What are you talking about? We know that since forever. So what do we get in Postgres? It's really the same code. Huh? Yeah, it's a bit different. We also get, yeah, that's right, it's nothing inserted, but do you know why? Rollback where? The whole transaction, right. It's really the whole transaction which is rollback. And you can, yeah, it's, we have something called statement level rollback in Oracle database. And this is really cool. It makes sense when I do the second insert that I do not lose all my work I've done for an hour or something like that. It's really dangerous. You can also use save points in Postgres, but nobody's using them. And I thought, why? Because it seems to be a hell of expensive. So, and even if you are want to use save points in your procedures, this does not work. You cannot use save points in stored functions in Postgres. Does not work. Of course, in Postgres you find extensions for everything, and there is some hacky open source project which provides that, but standard Postgres does not provide that feature. If you want to do that with SavePoint, you have to do it outside of the database. Nothing with SmartDB or something like that does not work. Okay, so in Postgres, I can implement that really with SavePoint, but then I cannot use it in stored procedures. Somehow I missed one of these challenges. Whoever thinks he wants one, the first one can get it. After I'm finished, the rest. So we come to the core messages, and somehow I'm a bit faster than usual, but okay, it's fine. We have a SQL standard, but from my point of view, it does not mean that you get the same behavior across the DBMS. Semantic, again, like the joke in at the beginning, semantic matters. You have the same statements. You do not have compile errors, but you don't get the same result or the same behavior. So to avoid problems, you have to test it. There's no way out. So therefore, every migration project in one direction or the other direction is not that easy as you might think. So these were just a small part of examples which I thought are interesting to show so that it's really just because it's SQL and something claims to be SQL compliant does not mean you have no problems, even if your application uses SQL compliant statements. I hope you enjoyed it a little bit and learned some small things. I promise you at least to learn something new. And I cannot say enjoy the rest of the conference. It's basically over, but I wish you a nice evening. Thanks.